Good morning, everyone. This is Daryl Morin at Advanced Wireless. I have the great privilege of being your host here today for our webinar, Connecting the Smart Classroom. Would like to thank you for taking time out of your busy schedule to join us here today, as we're going to be discussing some of the new trends happening in K-12 education and the challenges that they can present to IT professionals servicing this industry. So quick housekeeping items before we get started. At the very beginning, you may have a controller, a webinar remote controller on your screen. You can go ahead and minimize that by hitting the right arrow to kind of push it off so you make sure you can see the entire presentation. And you'll also see a questions box there where you can type in questions, and we'll try to get to all of those before we end the presentation today. If we're not able to, we'll make sure to follow up with you and email you or call you with a response. So with that being said, let's go ahead and get started. So for those of you who are already partners with Advanced Wireless, you know a little bit about our history. So I'm going to go ahead, though, and share just a little bit for some first-time individuals who are joining us today. Advanced Wireless has been around for a little over 23 years and actually started off doing wireless networking before Wi-Fi even existed, before it was the standard. As such, we have tremendous expertise in the field with regards to wireless LAN and broadband. And the initial systems that we implemented were used primarily in retail and manufacturing and distribution with these industrial handheld computers and barcode scanners and barcode printers. But due to our high degree of expertise in the environment, we've gotten pulled into other sectors, such as healthcare, education, and government as well. We're very proud to have a number of very successful and very pleased customers all around the globe. And I have a couple of you listed here today, everywhere from Carthage College, which once had a disparate wireless network system made up of various providers with varying degrees of success. We've successfully replaced all of those, now have approximately 1,000 APs across their buildings there to our great partners over at the Kenosha Unified School District, where we're providing wireless coverage to over 40 buildings and literally over 20,000 students and administrators and instructors. Even our great partner over there, St. Mary's here in Hales Corners, so we can do everything from single school to huge districts, etc. I know we have some members on too from the Hmong American Peace Academy, another great partner, and a number of others. And then you'll see some of our other customers, right, from our traditional roots in manufacturing and distribution retail. We're very proud to provide solutions to Harley-Davidson Motor Company, Rockwell Automation on a global scale, True Value on a nationwide scale, and the list goes on and on. So today, boy, we service customers now in over 11 countries, all 50 states here in the United States, as well as the Commonwealth of Puerto Rico. And as for those of you who are customers who are joining us today are aware, we're always just one phone call or one click away with technical support, providing up to 24/7 by 365-day technical support. So we're here today to talk about wireless networking in the K-12 environment, and obviously we've been seeing a tremendous change in expectations in wireless. Where wireless was once a nice to have, it has now become critical to the education environment. So I talked just briefly a little bit about Advanced Wireless. I'm going to be talking about one of our proud partners here whose solutions we'll be integrating throughout the presentation, but primarily it's going to be informative for IT professionals in the K-12 space. But that good partner is Extreme Networks. Founded in 1996, boy, they have a huge patent portfolio and are actually one of the largest providers of wired and wireless network equipment to the K-12 environment, as well as through secondary education. A little over 550 million. They are now the industry's fastest growing network systems company. And for some of you who are traditional customers or longtime customers of Advanced Wireless, you will know that they have purchased all the patents and technology, and boy, the brain trust that existed there that originated Symbol Technologies, one of the first two initial manufacturers to develop Wi-Fi radios, and that proud heritage lives on today through their products. Once again, for those of you who just joined, feel free to go ahead and minimize the GoToWebinar remote control by clicking the right arrow to kind of push that remote control off to the side. And then you can pull it out again if you have any questions. Just go down to the questions area, type them in there, and we'll see it here. While many of you know of the education installations we have throughout the Midwest, here's just a picture of showing Extreme's commitment to wired and wireless networks. Once again, a very significant player in the K through 12 space, as well as secondary education. So, as many of you know, we are living in a new reality today, where once we thought it was going to be more of a high density implementation when we had to support one wireless device per one student. Now we're actually finding that we're seeing multiple devices in many districts per student. So one-to-one is no longer considered high density as it used to be. And when you see the shifts in education, it's easy to understand why. You know, 70% of schools today are moving to some form of digital textbooks. 43% still don't have the capabilities of really customizing the network per the student's requirements, etc. And even 20% of kindergartners now are having some kind of internet-connected phone or other kind of device that are being implemented into the curriculum as well. So obviously that puts tremendous strains on districts and schools to provide the reliability, the performance that they need to ensure that the instructor is able to get into the classroom and do what they were hoping to do with that day's curriculum. While we do see, and obviously E-rate has made it more possible for school districts and schools to go ahead and implement technology, that doesn't include the addition of dollars for bodies to support that. So now you're being expected to support a whole new environment with a growing number of devices, exploding amount of bandwidth being consumed here, but with the same number of support resources. And that's why it's important to have centralized management and advanced troubleshooting with the solutions that are being implemented today. As I just mentioned, we're seeing exploding digital content and network traffic. In some environments, we're seeing it increase by anywhere from a third to almost, in some instances, 42% per year, depending on the maturity of the online curriculum being used by a particular school or district. And that is phenomenal growth when you think about that. The integration of personalized learning, which is beginning to pervade all K through 12 environments, online testing requirements. Obviously, we're all, for those operating in Wisconsin, all aware of the demands and the stresses that's putting on not only your internal networks, but on your network connections to the internet, beyond the Internet of Things, which all too much people forget about. The appliances and other devices that are being thrown on wireless networks that go above and beyond the student device. And then obviously we're starting to see the hints of virtual reality making its way and introduction into the classroom as well. So you can see where the exploding digital content driving all this traffic, whether it's the e-books or e-textbooks, video lectures, the use of YouTube videos in curriculum, which is becoming more and more prevalent. Obviously, all the web pages that are being viewed, online testing, iPads, Chromebooks, notebooks, smartphones, even robotics and head-mounted displays. All of these are different devices, and while many of them are listed as being Wi-Fi compliant, each do so to a varying degree. Just because something is Wi-Fi compliant doesn't mean that they're all equivalent with their true throughput that those devices are able to achieve, as well as the range. So once again, as IT administrators, we're seeing instructors and curriculum developers getting excited about all types of new devices that can be brought onto the network, but we all must remember that they all have varying degrees of wireless capabilities, and in many devices we found questionable drivers for the wireless radios that are inside of those devices. So it makes your job all that much more challenging. I mentioned a few things that are really driving the digital content and traffic over the networks. This includes the personalized learning that we're beginning to see. It's really making itself throughout all K through 12 institutions, particularly here throughout North America, as you can see here. It's really exploded due to the success it's having in improving learning and outcomes for students. And so here's the results of some pretty in-depth surveying that's been done around personalized learning. Personalized learning above, is supplanted adaptive learning and collaborative classrooms, et cetera, is becoming the #1 way to present and teach to individuals. And when you go through and when they surveyed, they see that the #1 thing you need to succeed when implementing a personalized learning curriculum is professional development, which I think would come as no surprise to anyone. But due to the tools that are needed, I know what surprised me, quite honestly, was what the second rated item that instructors and administrators said was critical to being able to implement this type of learning curriculum, and that was reliable Wi-Fi, as it is heavily dependent on tools that the instructors can customize on a student-by-student basis. So while we knew it would make the top 10, didn't realize the value that instructors and IT professionals put on having that reliable Wi-Fi portion there. The types of tools we're seeing used and that are pervading, that are cloud-based, is obviously we see a tremendous amount of Google Classroom and Google Apps being used, some iTunes University, Class Dojo, Activate Learning, Education Elements, the list goes on. And we know that that there will continue to be more coming online. And as they continue to work to improve the student and instructor experience, we're going to continue to see growing levels of bandwidth needed to provide that content, which is becoming more automated, which is including more and more video, and trying to simplify the interface through the continued complexity and traffic that will drive those simpler interfaces. Many of you I know that are on that I'm familiar with have also are continuing the trend that we see nationally going to Chromebooks and the dominant role that it's playing. 60% of schools out there already have or are planning to implement Chromebooks. We used to see the iPads being the predominant, here just 6-7 years ago. That's really been supplanted by the growing and cost effectiveness of the Chromebook solutions that Google has created, and the very either free or cost effective web applications and management systems it's wrapped around those. That being said, there's been a huge drive to try and reduce the cost of the hardware, obviously, which has made Chromebooks so affordable. Down here, you'll see 56% of Chromebooks being used today are from Samsung, 28% Acer, 24% HP, and you'll see the others listed there. That being said, we've seen a tremendous variant introduced here. As the hardware costs continue to be driven down, we continue to see that sometimes the wireless interface card and the drivers behind those aren't as robust as we would like. As such, we've had to take it upon ourselves to try and overcome some of the shortcomings that we'll find in those drivers. For those of you who are currently using some of our solutions, such as that take advantage of the Extreme Wing technology, we are doing things behind the scenes to actually force devices to roam, where many of the drivers are written to connect to an access point and put a death grip holding onto that access point. We are having to do things behind the scenes that will proactively force them to roam. in the wing network. While a lot of other solutions really don't roam all that well, we find that it not only assists with, obviously, when you're moving between classes, et cetera, but in load balancing. When we want to, when we have a device that is on an access point that is carrying a heavy load, we do want it to feel free to roam over to another device that may have excess capacity left, reducing co-channel interference and balancing the load across the wired and wireless networks more effectively. Then we see the online, the popularity of online testing. Of course, we know here in Wisconsin, pretty much it is a mandate that everything must, certain tests must be done online, etc. And then here's something that typically gets left as an afterthought, the Internet of Things and the smart school. And we're not just talking about things like smart boards, but it goes way beyond that. And you'll see that the majority of school districts right now are implementing smart school technologies. And that can range from, not just your interactive whiteboards or smart boards, but the cameras and video cameras that are being put on there for security purposes, etc. The tablets, the e-textbooks, student ID card readers, the lunch card readers, 3D printers, and even most HVAC systems, the heating and air conditioning control systems and sensors are communicating via Wi-Fi. Growing number of electric, lighting, and maintenance features are doing that. Temperature sensors, attendance tracking devices, wireless door locks, etc., are all coming back to that backbone, which has been proven to be more cost-effective when you address it and attach to it wirelessly. So that's just a little bit about the trends we're seeing out there. Obviously, we could probably spend a whole day just talking about those. But now let's talk about, we're going to just provide some key considerations when you go ahead and you're looking at ways to design your wireless network. So there's a whole lot of hype. Sometimes people get lulled into looking at what are the fastest speeds or data rate that an access point can present, and because faster has to be better. But we all know that there is a challenge today in K-12 education with regards to funding. These are nonprofit entities that don't have limitless access to dollars. You're now putting in technology that is going to be earning revenue, obviously, as your success is measured in educational outcomes. And as such, we want to make sure that we right size and recommend the right products for those educational institutions. So one thing you're going to hear for many of you who are newer to the wireless environment is a thing called channel bonding. So when we talk about Wi-Fi channels, whether it's at 2.4 gigahertz or 5 gigahertz, the way the 802.11 system was designed was that we have 20 megahertz channels. And what has happened as the standard has evolved is we're able to, and they've designed into the standard, where if we have a channel, 20 megahertz channel, and we want to get faster data rates, and we've already reached the theoretical limits on compression, well, let's bond another channel. Let's take two 20 megahertz channels, put them together to create 40, and that's what we call channel bonding. But now you're consuming two channels, and you're distributing the power that was once only spread across 20 megahertz across 40. So your signals now become weaker. You've doubled your throughput essentially, but now you're also getting interference now, co-channel interference across two channels instead of just one. If you go up to 3, or if you bond up to 4 channels, now you're consuming pretty much all of the channels in that given area, and you're going to be interfering and getting interfered with by others. So we've often find, and we'll get into this a little bit more later on, that it's not so wise to run your access points at the 1.3 gigabit or faster settings, as you are really weakening your signal and opening up yourself to a whole lot of co-channel and other sources of interference. That's why we traditionally see in K-12 environments, we stay with the 20 megahertz, or at best a 40 megahertz channel where we're only bonding 2 channels to make sure that we're getting the most efficient transmission of data. So in this instance, faster is not always better. Cleaner air should have a higher precedent than faster, because in the end, when things aren't having to retransmit as much, when people are able to get on and off the air quicker, you actually find you get better true throughput. We get the question, you know, I have these really fast access points. How come I'm not seeing the same data rates that's advertised on the access points? A couple things to remember. There's a difference between data rate and throughput. And a lot of that can vary, even though they all are adhered to the standards. We've seen from radio manufacturer to radio manufacturer dramatic differences in what true throughput is versus the data rate. As a rule of thumb, we use, you can count on about 50% on quality enterprise grade devices, 50% throughput of what the data rate would be. So if you're connecting at a data rate of 300, we believe it is reliable to use about 150 true throughput should be the reading there. But once again, that will vary between manufacturers. And I'll go even further to say, even if you have the same manufacturer, but drivers are written for that radio by different folks, you will see dramatic difference, once again, in throughput as well as range. So always remember the difference between data rate and throughput. You'll also will begin to take a hit too when you see that the excessive use of resources is in an access point. So we often get asked, well, how many devices will this access point handle? And we may say 50, or we may see 100, or some variant there in between. But that is also assuming that the client devices are going to be spread equally between 2.4 gigahertz and 5 gigahertz. We would not expect even the strongest access point to be able to handle 100 devices on just one radio inside of the access point. So these are things to take into consideration. The type of device we're having, does it support 2.4 only, or does it also support 5 gigahertz? How robust are the drivers? Does it support multi-user MIMO? All those types of things, as well as, you know, what is the congestion and access like through your network, whether it's internally or in your connection to the internet, and other environmental factors such as quality of signal, interference, and those types of things. We're just now starting to see that MU MIMO is becoming more prevalent out there. It allows access points that support multi-user MIMO or Wave 2 MIMO to talk to multiple devices literally at the same time, where previous technology was just talking to different devices and it may have appeared at the same time. It was actually time slicing, transmitting data to one client device at a time. Now with multi-user MIMO, we can actually take independent streams of data and send them at the exact same time to different devices. Much more efficient use of spectrum, but it's only supported and will only work on devices that support multi-user MIMO. So we've seen the introduction of it in the new Samsung phones, starting to see some of it in Apple, but we still haven't seen the Wave 2 technology really make it all the way through to all the different versions of the Chromebooks, laptops, etc. So once again, MU MIMO does have advantages, but it will only work with MU MIMO clients. So right here, I have a little example. Most clients are 1 by 1 by 1. And what that means is it will transmit on one antenna, it'll receive on one antenna, and it can only do one data stream at a time. When you see 2 by 2 and 2, that means it's transmitting on 2 antennas, it's receiving on 2 antennas, but it's sending 2 streams of data. You can see 2 by 2 by 3, which means, yes, they're still only receiving and transmitting on 2 antennas, but it's sending 3 streams of data. And you'll see 4 by 4 by 4, etc. But these are all things that you have to remember. While a lot of features and functions are being thrown in there and a lot of things are being done to give you that wow sticker effect, remember that in the end, in most K through 12 environments, we'll rarely recommend that you go that high, simply because we wouldn't recommend you implement that, because your signal would be so weak and you'd be so susceptible to interference that you would actually be slowing things down by attempting to go faster. And as I mentioned before, throughput versus data rate is always something you want to be cognizant of. So other things you want to consider, obviously your building type, all metal lockers. If they go from the floor to the roof, obviously means you're not going to get a whole lot of signal from the classroom out into the hallway or back. Is it open air or a walled environment? How dense are things within the rooms, including people, right? Because we have moisture inside of us and we do absorb signal. It's important to know how many mobile users are you planning on having in a room, whether it's in a classroom, a gymnasium, an auditorium, or cafeteria. Those are all key questions we ask here at Advanced Wireless right off the bat, because sometimes it's more cost effective to select the right access point for that particular room than trying to put in the latest and greatest and biggest, which would be overkill and not probably the wisest use of school dollars. Application performance requirements. Do I need to provide wireless voice over IP service? Am I going to be doing a lot of video, a lot of file transfer, or am I going to be doing basic web browsing? Those are all things that you want to define for your provider. Who is your client? Is it going to be administrators, instructors, students, guests, any other variant thereof, the types of devices you're using, and security. Is it going to be Active Directory or passphrase and captive portal, or combination of those? One thing I will note here that I wish was included in the slide was the 802.1x. When you do some kind of authentication, the Extreme Wing solution does allow you on a user basis to put your clients onto different VLANs. So instead of having to advertise, let's say, 3 or 4 or 5 wireless networks, which means time slices are being divided to listen and to transmit and receive across all those wireless networks, perhaps we can cut that down to 1 or 2 wireless networks, where based on our login, the system will automatically throw us onto the VLAN that we should be allowed to access. Once again, making much more efficient use of the spectrum and the time slicing that's going on, allowing us to be more efficient, more effective, and increase actual true throughput. So other questions, as I mentioned before, how many users per room, how many devices per user, how many devices per AP, and I'd break that down to say even radio. Hopefully the vast number of devices would support both 2, 4, and 5 gigahertz. What's my estimated wall attenuation, so I have an idea on my range. Making sure you're pulling the cables for APs where they're truly needed and not moving the AP to the location where there is a cable. Like to minimize that when possible. Is there any physical protection that we need to place around an AP to keep it from being potentially damaged by a student or someone else? Or is it an environment such as a gymnasium where you could have things such as basketballs or volleyballs or soccer balls impacting and damaging the equipment, etc. And then obviously I know there's always the question of scalability and manageability and troubleshooting. So some other things, one other thing that we really strongly, I know there's been a tendency to try to move away from this because the self-configuration tools from some of the manufacturers has really gotten to be quite good. We still do recommend wireless infrastructure analysis to make sure that things not only operate properly, but that they're tuned to the point where you could really take advantage of enhanced configuration options that you'll find in a lot of these systems. There's 3 types of wireless infrastructure analysis that can be done. One is predictive, where you simply provide drawings of your facility and information of the composition of the walls, etc., and you kind of predict where what coverage would be like, but no actual in-building signal analysis is being done. Then there's the passive, type of wireless infrastructure analysis where a trained individual goes in with software and takes an access point with him and listens to the signal strength of the beacons that are coming off of that access point. So now you're getting a little bit more better information with regards to the signal loss that's going between the walls, etc. And then you have the third type, which we recommend wholeheartedly, which is active, which is we're measuring the quality of the signal to and from the access point. And here's why we believe that's so important. Most access points will operate with the maximum radio output strength per radio of around 100 milliwatts. So that's a lot of power. Most consumer grade and types of devices that we tend to see, like Chromebooks, etc., in an educational environment, have radios that will range anywhere from a radio output of 24 to 32 milliwatts. So what that means is I have this access point that's shooting out at 100 milliwatts, and when I look at my device, it says, yes, I have great signal strength, because it's just simply reporting on the strength of the beacons, the radio beacons it's hearing out of the access point. However, that doesn't mean that the device has enough wireless transmit power to get the signal all the way back to the access point. So that's why we like to go in and measure the to and from signal quality to make sure that you get the experience, or the student gets the experience, as well as the instructor, that they need and they demand to get the outcomes you're looking for. So these are all things we're sharing with you to take into consideration when you are looking to have these services done. And obviously, we'd appreciate the opportunity to provide those services to you. We also strongly suggest that whenever you have a site survey done, that it be done using the actual hardware you're looking to implement, because you will see tremendous variations in performance and coverage range, even between manufacturers at the enterprise level. Always make sure that it's conducted per the requirements of the applications you're looking to use, and that it's using the configuration settings that must be configured to meet your actual requirements, and then that it is done to the requirements of the client devices you have. I mentioned before how there are numerous device types out there that's ever growing, and each one has a varying degree of radio quality, and as such, what we typically do is design to what we're able to identify as the weakest radio out there, so that we're assured everyone is able to access that wireless network. Other things to watch for: hidden concrete walls that may be behind drywall, densely populated storage room, lead walls. We have run into this sometimes in a number of occasions, etc. So there's always been that question, do I put them in the room or do I put them in the hallway? We had begun early on, the trend was to put them in the hallway because we were looking to provide access more than density, but given the explosion of the personalized educational experience that's being delivered today, we are almost 100% recommending that individual access points, the right sized individual access points, be placed in the classrooms to make sure that we get that quality experience that delivers the outcomes that are needed today. That being said, we do believe strongly in identifying the number of devices that need to be supported concurrently per room, and that does differ between the classroom, as I mentioned before, cafeteria, auditoriums, or other gathering spaces. Be mindful, for those of you who are in a multi-floor environment, that radios do transmit, right? Not just horizontally, but vertically as well. And there's co-channel interference that must be addressed and designed for it there as well. I mentioned before the importance of understanding the channelization and the channel bonding that's taking place. So here's this one, and I want to credit Divergent Dynamics for this slide. If I use the root level of the 802.11 standard for channel width, I'm using 20 megahertz. So these are all the channels across the 5 gigahertz, right? I have 1 through 13 at 2.4 gigahertz, but at 5 gigahertz, I have all these channels to choose from. Some of these right here in the middle, we eliminate upon our implementation when you are anywhere near an airport because they can, per FCC, we're required to scan for radar. And whenever it senses any radar, it'll take those APs offline for a period of time and move them over. And obviously that would be very interruptive to the educational experience. So we remove those. Typically we use the bottom 4 channels and the top 4 channels to make sure that no instruction time is impacted. However, when we go to a channel bonding environment where we're bonding 2 channels, now you begin to see there are less channels available, obviously, because we now are making each channel equivalent, or the available channels equivalent to 2 channels, where we're doing that channel bonding. So the number of available channels gets down, the signal begins to get weaker because we're spreading the same amount of energy across more spectrum. But we're also going to be more susceptible now to other forms of interference and interfering with others. As we go to 80, the number drops even further, and 160. That being said, most clients out there today don't even support this and won't ever support this. So just something that to go a little bit beyond the marketing hype that sometimes we see out there today. In most environments, we do see, and this it says 2.4 gigahertz, but this holds true for 5 gigahertz as well. We do see people staying with the traditional channel or 2-channel bonding, and that may be reflected in your configuration. And when you just see the channel, that means you're running at 20 megahertz. If it shows the channel plus a W, it means wide, which means it's binding 2 channels. If you see WW, it means it's binding 3 channels, or 4W or 3 Ws, that means you're binding 4 channels. So just so you have an idea. But once again, we like seeing this because devices are not having to wait for others. They're getting a nice strong signal when designed properly, and they're able to get their data up and off very quickly with minimal co-channel interference. Especially in the 5 gigahertz area. Another thing you want to take into account is traffic shaping and rate limiting. So we've seen this a couple of times so far, where we've had educational institutions have really fast bandwidth access to and from the internet, yet we continue to see high latency to the point of, in some instances, where they were unable to use any of the video curriculum that they were hoping to use. And one of the things that most people need to be mindful of is that applications such as YouTube and other types of applications, even those now designed for the educational environment, are becoming very intelligent. They want to provide the highest quality student or instructor experience possible. So at the very beginning, when you're initiating the session, they're evaluating the bandwidth that you have available to you, your internet access speeds, and as such, they will provide to you the highest quality experience possible. And I use YouTube as an expression of this. And I just copied these earlier this morning off of the YouTube website. If I'm getting a 4K video, 60 frames per second, it's going to want to use anywhere between 20 to 51 meg per device. If I'm using a 4K video at 30 frames per second, it's going to be using anywhere from 13 to 34 meg per device. Now, compare that to if I'm doing 1080p, it's 3 to 6, and typically we see about 5 to 5.5 meg per device. So if you have a 100 megabit pipe, it's very obviously to see how fast that can be consumed. If I have a gigabit pipe, it's very easy to see now how that can be consumed. So one of the things that is wonderful about the Extreme wing-based solution, on all of their newer access points, they have the ability to do application visibility and control. And not only can this be used to report back to you what applications are being used and how much bandwidth individual users are using, what applications they're using, etc., but we can use that information too to say, hey, if we see YouTube traffic or other video streaming traffic here, we want to limit that application to 5 or 5.5 megabits per second, and make our students suffer by having to use HD video instead of 4K video, simply because not enough people see the value in consuming 50 megabit per second for 4K. Typically, we'll see those demands being used in the healthcare environment, et cetera, where they're having to really transmit medical records that they need to see great degrees of detail with. But in education, typically we see 1080p is fine enough, and it really helps protect your bandwidth there. So that's one type where we can limit traffic by application, by user, by device, etc. But then there's also another rate limiting feature that is included, and typically we put this on more guest style networks, where we want to make sure that the predominant use of the wireless resources are being used for internal operations, right, such as educational purposes and curriculum, versus guests who just may be visiting, etc. So typically we generally recommend putting a generic rate limit on that wireless LAN or devices on that wireless LAN to make sure they never pull the resources from your primary purposes. That being said, in the Extreme Wing solution, we can schedule those. So you can say, okay, after 3:30, when class is let out, everybody can go the full speed or any variant thereof. So going to get a little bit into how Extreme and Advanced Wireless with our solutions help address some of these issues. So the architecture that Wing uses, and that does stand for Wireless Next Generation solution, is a distributed architecture where almost the exact same software, firmware that's running in a controller is running in the access points, meaning we can do everything that a controller would typically do. And instead of having all that traffic routed to a controller and then sent out again, where we're literally doubling the amount of traffic, the access point can put it right on your network and leverage the speed of your network right there at the edge. As such, it's redundant, it's self-healing and self-optimizing, and provides unmatched security as things are being identified right there at the AP level. We've had numerous occasions where in the past, using older technologies, where everything was forwarded to the controller, where a device would pick up something, potentially at home, either intentionally or unintentionally, come into a school environment, and the device would launch a denial of service attack. And while yes, the controller, the firewall on the controller would stop it, it was still degrading the performance of the entire network as those packets were making its way from the access point through the network to the controller. What Wing allows you to do is have the radio at the access point stop the attack and not allow it, so it never touches the wire. Very, very intelligent, obviously making it the most secure network possible, as firewalls are not just put on network interfaces, wired network interfaces, but on the radios as well. So it provides unmatched security, all that intelligence, provides for that application visibility and control, designed for rapid, predictable installation. And all of the Wing access points actually self-configure, so you don't have to worry about getting it wrong. If you have your wireless management system configured properly, you can add an access point, it'll automatically put itself in the right place, draw the right configurations, so you can make sure that if one access point is configured properly, the rest are all configured the same. And we found that it's more cost effective to have your cable pullers install the access point at the time they're pulling the cable than having to send another person out there to mount it. And you can do that because there's zero touch access points. They'll get on your network and automatically self-configure. The Extreme Wireless system is continued to have a record of being the highest throughput wireless LAN product on the market, full featured, it's location aware, multi-security available, and each device supports mesh networking and a variety of other features at no additional cost. Limitless scalability, maximum performance, and what's nice about it is in most environments, even if the controller or manager of the wireless network goes away, the APs are so intelligent, they are still going to stay up and run and provide access to your users. That being said, if you do require some kind of centralized authentication, while the APs will be aware of authenticated individuals, if you lose access to your radius server, et cetera, obviously that will impact your ability to jump on. That being said, Wing does have built-in where if you do not have access to your Radius server, it can throw you over to a secondary captive portal where you could type in a pre-approved password and still be able to access the network. So there's even redundancies beyond that. So here you're going to see the traditional hub and spoke architecture, which still gets used quite a bit, and it may be well suited for certain environments. But the Wing architecture here, once again, allows your client device to jump onto an access point and take that traffic directly over to another device, eliminating the dual path of having to go to a controller and come back out. So much more effective, and has the ability to leverage the speed that you have out at the edge of your network. Every AP that comes out of Extreme Networks has that controller-like functionality. It can actually, each AP can actually serve as a controller for up to 24 to 64 other APs, depending on the model of the AP, because of the memory it has. It does have a scaled down amount of functionality in it, just because of the amount of memory and storage resources it has relative to a full manager, but it still can control and do most of the same advanced features. Each access point has a L2 through L7 firewall that is ICSA certified, that is placed against a virtual interface, the wired interface, as well as each radio inside of the devices. So very robust, provides for deep packet inspection, integrated radius, true rogue detection, has integrated DHCP servers if needed, Bonjour gateways from meshing capabilities using Mesh Connects, and so much more. So very, very intelligent solution. One thing that has really come very far, very fast is their guest access solutions. It used to be where there was always just a predated form that you could fill out some information on through their captive portal to gain guest access. They've now provided features, and you can always go to an outside registration website too. It supports that, but they've allowed you now to create your own forms and collect whatever data you may want to collect, depending on your environment, or to pre-print one-time usernames and passwords, create those, and once a device comes into your network, it remembers that device. It will never have to, the user for that device will never have to enter credentials again. So it's self-learning. It's one-time registration of the device, which is, we've seen really simplified the BYOD experience for administrators. Instead of having to try to copy MAC addresses or come up with other solutions, you pre-print these IDs out in advance. The user, particularly for the younger grades or the lower grades, they're able to, with the assistance if needed of an instructor or a parent, get their BYOD device on the network, and that device will work for the remainder of the school year. It gives you the parameter there, so where you can set the expiration date, whether you want them on for 1 day or you want them on for, you know, the length of the school year, etc. You can set that, and the database will flush itself at the end of that period of time, and you can create users for the next educational year. So very, very flexible, a lot of capabilities there. There's all types of virtual managers here, whether they be in the AP, through the virtual controller implemented there, or through any of the appliances, or through the VX9000 virtual manager, which can now manage over 25,000 APs per instance. So scalability typically isn't an issue for these for the Extreme Wing wireless system anymore. And they also have the Extreme Cloud. So for those of you who want all the advantages and data storage and analytics that you'd find in a virtual manager, but don't have a VM environment of your own, you can go ahead and get on the Extreme Cloud system. One thing that's important, Extreme is really one of the only providers of wireless access points that allows the same access point to be used as a virtual controller of other access points, or to be managed by an appliance, or a VM, or to be managed by Extreme Cloud. Most other providers make you pick and choose your access point Nope. Extreme believes in protecting your investment, so you can use an access point in any one of those configurations. So you can modify and adapt as your needs may modify, grow, and adapt as well. We mentioned before, the same firmware is pretty much throughout all the access points. These are the access points we typically see used in most educational environments. There's a whole lot more that are available to you. The big boys that we tend to use in areas like auditoriums and other large gathering spaces where you could have hundreds or thousands of individuals would be the 8500 series. These would be the ones we would put in. We have one environment now where we need to be able to support over 1,000 concurrent sessions that are active, passing traffic at once. That's where we're using the 8533s and 8432s. For your typical classroom environment where you're going to have 50 devices and it supports more, but we want to make sure we design for that pleasurable experience. So when we are going into rooms such as classrooms where you're going to have 35 to 50 devices concurrently talking, all passing traffic at the same time, we recommend the more cost-effective 7632. Here, actually, you'll see it listed twice. This is it right here. Forgive me. And then for outdoor environments, the 7662. There are also a number of other ones, but these are typically the ones we see being used in the educational environment. Once again, the larger access points do support the higher data rates, the 1.773 here, but once again, we would really only turn that on in places where it's isolated, where we wouldn't be creating more interference for those around us, etc. And even though the 2.4 gigahertz radio supports speeds up to 600 megabits per second, I'll be the first to tell you that's a little bit of hype because you won't even find a client out there on most laptops that can go that fast, etc. But once again, transmit, beamforming, and signaling, all those types of things you'll find in this and the other access points as well. 8533, even more robust, even more processing power for handling even higher numbers of people concurrently. And then this is the one we typically see used in the classroom. Yes, the 5 gigahertz maxes out at 866 megabits per second, and that's using the 2 channels. Once again, we very rarely would ever recommend using 3 or 4. So this has a maximum of the 2 channel bonding, which gets you up to 866 at 4 gigahertz and up to 400 at 2.4, etc. Once again, very, very cost-effective solution, and this is the outdoor variant of them, the 7662. We're seeing more and more of these access points being used to link stadiums in addition to providing classroom coverage. And that is not only helping, obviously, teams be more successful on the field or on the track, but it's also giving the media immediate access to post and receive information. But more importantly, we're seeing a dramatic increase amongst the students and members of the community and community pride, because now they're posting things on social media, etc., that are really positive about their experiences. So it's been really neat to see the growth we see there. As I mentioned, all the devices pretty much from Extreme that have Wing have mesh connecting capabilities. It's originally designed for the U.S. military to link tanks together, etc., on the battlefield, but that allows us to have point-to-point or point-to-multi-point connectivity. So now we can connect buildings, we can be a backup network connection for connecting buildings, as well as affordable access out to things like a dugout or a press box at a stadium and much more. All of this gets wrapped around and managed by Insight, which is the graphical interface and advanced analytics that Wing uses that allows you to see the true usage going on by your entire network, or by school, or by floor, or by room, or by user. It's that granular. It takes you down. You can see trending. You can see areas that you may need to address with this advanced predictive analytics. And you can also see very quickly if you're having a user is having a client wireless issue or if it is something else going on there. I know that's always one of the most frustrating things we would hear prior to the use of Insight is, if the coffee is cold, it seems like everybody would blames the wireless. It is the problem for everything, but this allows you to go in very quickly to see if a client is associated, is transmitting data, at what data rate, the usage level and resource level through the access point is talking through. So within seconds, you can identify if this is an application issue or a client device issue, or perhaps even a user issue versus a wireless issue. So I know we've covered a whole lot of topics here really quick. I don't see any questions yet, but this would be the time to go ahead and type them in right here in your remote control here. I see one message here. Oh, yep. I said if we could present this information elsewhere, provide copies of the presentation. Yes, just go ahead and email me at dmorin@awimobility.com, and we can go ahead and present or provide a copy of this presentation. Are there any other questions? If you have any, just go ahead and type them right in there into the question box. If not, feel free to call with any questions or concerns or inquiries you may have. We're at 888-238-9473, and I am at extension 103. Once again, 888-238-9473. And for those of you maybe looking at your phone, yes, that spells out 888-ADV-WIRE for advanced wireless. And as always, feel free to visit us at www.awimobility.com. Once again, I want to thank all of you for joining us here today. And if you have any suggestions on topics you'd like to hear about in the future, please feel free to give us a call or shoot me an email on that as well. Once again, thank you for joining us today, and I wish you a pleasant day and a wonderful week. Thank you.